No more trial and error approach when testing JavaFX. Here are top 7 mistakes when testing JavaFX applications and ways to avoid them using the TestFX framework. Mistake number 1. Updating the UI of the fixed thread. JavaFX creates an application thread when the application starts, and only this thread can render the UI elements. But the tests run on the JUnit thread. And so, if you try to perform the UI actions, it may result in illegal state exception, random null pointer exceptions, or deadlocks. So, what can we do? Write to the UI to mutate controls on the fixed thread. If you use the fix robot class, you can wrap the interactions using the robot interact method. Read from the UI to get text snapshot pixels or query the layout also on the fixed thread and return a value. Mistake number 2. Incorrect bootstrapping when using Spring Boot. TestFX owns the stage, Spring Boot owns the beans. So, if you boot Spring without giving it the TestFX stage, the beans won't be able to use it. Plus, if you use FXML, FXML loader uses a different class loader from that of Spring. Controllers that Spring create aren't of the same type as the FXML asks for. So, what can we do? Make FXML loader use the same class loader as Spring in the application code. Use the start annotation to wire up the real stage and dependency injection to inject fakes. Don't call new FXML application start if this code boots Spring internally. Mistake number 3. Confusing handler wiring with the real user input. If you call the controller methods directly in the UI tests, you are testing the code wiring, not the real event path. As a result, your tests may pass but miss important bugs. Or the tests may hang and fail because the input never fired. What can we do? Well, obviously, avoid calling the controller methods directly in the UI tests. Use robot click-on or similar methods to test user interaction and UI behavior such as pressed or hovered visuals and so on. Use button fire or similar control methods to assert handler effect. In the headless mode, if the platform can do something, like going full screen, assert a proxy signal, like pseudo classes or button state. Mistake number 4. Racing the fixed event queue. JavaFX is a single-thread kit, so the UI events get queued. If you assert in tests before the queue is drained, you are testing the UI that doesn't exist yet. Therefore, tests pass or fail unpredictably, depending on the CI, CPU, moon cycles, or whatnot. What can we do? In the case of simple changes, you can use the wait for async-utils class and its method wait for fix events. This method helps to wait before the event queue of the UI is drained. In the case you are waiting for observed outcomes, you can use the wait for method to wait for some condition to be met. Mistake number 5. Assuming pixel-perfect equality across platforms. The pixel colors of JavaFX can differ slightly on various platforms due to various reasons. If the tests assert the exact RGB equality on all platforms, the tests may pass locally and fail in CI or on another machine. So, what can we do? Don't assert the exact color. Compare baseline to the change state and allow for some tolerance in color and pixel density. In addition, we can allow for a small absolute difference when comparing colors. Sample pixels inside the shape, not near borders. This will help to avoid having different colors if the borders blend with the background. Mistake number 6. Misconfiguring Headless CI. Running JavaFX tests in CI differs from the standard testing process. These tests must run in headless state and be backed by Monocle. But it is not enough to simply wire the Monocle. Tests that pass locally may fail in CI due to multiple reasons. UI tests that run in parallel, required modules are locked down, tests assert platform features that don't exist in headless mode like full screen. So, what can we do? Well, first thing first, add the dependency for the Monocle. Then specify all required modules in a separate plugin with the add opens flag. The demo applications that I used in this video were developed and compiled in CI using Liberica JDK bundled with JavaFX. So there was no need to add any extra dependencies on JavaFX. But if you add the dependencies on JavaFX manually, you may have to use the additional add exports flag. It allows compile time access to Glass internals. Then, in the workflow file, make sure to install all necessary native libraries for JavaFX. Then, run the tests with the correct profile. Don't forget to install Java or add the dependencies on JavaFX, or you can install the JDK with JavaFX bundled already. So, for instance, the file on the screen installs Liberica JDK 21 with JavaFX in the Setup Java action. Mistake number 7. Entangling business logic with the UI. Last but not least, testing business logic with the UI is not the best practice. Just as you separate controller and service methods in tests for web apps, you should separate testing the business logic and the UI in JavaFX applications. The domain logic tests should not coexist with the UI test in one class. So, what can we do? The best solution would be to move the business logic to a separate view and test it with the plain JUnit tests. Follow these recommendations and you will get rid of JavaFX testing headache. In the description, you will find the links to the projects that were used in this video and plus to the article that describes each mistake and remediation path in more detail. Don't forget to like this video, subscribe to our channel, and until next time!